Hey everybody, it's Mr. Carr again. Today we're going to be doing 6-7 day 2. We're going to continue solving our radical equations. We're just going to go over an example that's just a little bit trickier than some of the other ones we've done. And that's when we have radicals on both sides. Here's the thing. It's still a similar process, okay? So if I look at this radical here with the kind of a little bit more going on with it, we have the square root of x minus 12. We cannot combine these together, okay? They are not being multiplied together, and they do not have the same, they're not like, for example, if we do 2 square root of 5 plus 3 square root of 5, I can combine those together because they're both square root of 5. These are different square root numbers inside. They're different radicands. So instead, we are going to start with squaring. As long as this is the thing that's already isolated, like where it's got the binomial inside or something else inside like that, we can square it like that. So on the left side, that's easy. It just becomes x minus 12. But on the right side, you have to multiply that properly. We are going to be distributing here. It looks like this. So that means I'm going to distribute the 2 and distribute the negative square root of x. So 2 times 2 gives me 4, then minus 2 square root of x, minus 2 square root of x, and then negative square root of x times the negative square root of x. So if I multiply 2 square root of x's together, that just becomes an x. And I'm doing negative times a negative. So combine my like terms here. So that means x minus 12 is equal to 4 minus 4 square root of x plus x. Now it looks like the problems we did on the previous lesson. The goal here is to isolate this radical. Okay, so as long as I have this binomial one isolated first, I'm going to square both sides. And now the goal is to isolate this one. So I'm going to do that by subtracting 4 to both sides, and I can subtract x to both sides. Well, that worked out nicely because x's will just cancel out. Negative 12 minus 4 is a negative 16, and that equals negative 4 times the square root of x. So now I can divide by negative 4. So I get a positive 4 equals square root of x. And then just like before, we square both sides. So 16 comes out to x. Okay, so again, we got to double check for any extraneous solutions. So I'm going to do this real quick. I'm going to do the square root of 16 minus 12. Does that equal to 2 minus the square root of, square root of 16. So square root, this will become the square root of 4. Over here will be 2 minus the square root of 16. That'll be 2 minus 4. Square root of 4 is 2. And then on the other side, I get negative 2. That's impossible. This is one of my extraneous solutions. Okay, so because it's an extraneous solution, doesn't exist. So that means if there's no solution at all because my one solution I solve for, x equals 16, that's extraneous. My real answer here is no solution. Nothing exists that I can plug in for x here and here that makes this a true statement. Okay, and this is just that little bit of an extra challenge. So what I'm going to do is on the next example, to check your progress, feel free to pause it real quick and try it on your own first. Well, I'm going to get it set up and start going through on here. Okay, so just like last time, I've got my binomial already isolated. So I'm going to square both sides. So this becomes x plus 5 now. Over here, we're going to be distributing negative 1 minus the square root of x, negative 1 minus the square root of x. Okay, so we distribute that. That's negative 1 times negative 1 is a positive 1. Positive square root of x. Right here, it's another positive square root of x. And then here is a positive x. Okay, so then I combine my like terms together. So I have 1 plus 2 square root of x plus x. So I can then subtract this over and that one over. So that's gone, and that's going to be gone as well. So 5 minus 1 is 4 equals 2 square root of x. And then divide both sides by 2. And then I can square both sides from here, and I get 4 for x. So just to be on the safe side, we're going to double check that. Is the square root of 4 plus 5 equal to a negative 1 minus the square root of 4? Okay, so this will be the square root of 9. So we negative 1 minus square root of 4, which is minus 2. Square root of 9 is 3. Negative 1 minus 2 is a negative 3. That does not equal, so that means this is not an answer either. So my real answer here again is no solution. Okay, so that's our process for finding it. Very similar to before, just make sure that you are squaring first, and then you're isolating this radical, And then eventually you'll have to square that as well. But always check for extraneous solutions. All right, that's it for 6-7 day 2. Take care, everybody.